Good afternoon, everyone. So this is my fourth lab meeting on this current topic. So here we are just focusing on the Convective Extreme El Niño in ramp up and down experiment. Here the current title is the irreversible change of the occurrence of Convective Extreme El Niño. So the motivation for the current study comes from a recent study published in Nature Climate Change in 2021. So in their study, they focus on the intertropical convergence zone hysteresis behavior. So in the same study, they show the precipitation difference between the CO2 reduction phase and CO2 increasing phase. And while showing that one, they suggest the global climate in the ramp down phase may experience anomalous conditions similar to those of a persistent extreme El Niño period. So in the same study, in the later part, again they showing the precipitation difference over the land. They highlight certain regions may experience enhanced wet and dry conditions. And then such enhanced wet conditions, it means the increases may be related to the precipitation pattern similar to permanent extreme El Niño. So however, they focus on the mean state change, but they don't discuss about the extreme El Niño. So then we are interested to further investigate to find answers for two things. One, how this extreme El Niño will change, and then the other one, if there are such changes, what will be the impact. Then, since we are focusing on the convective extreme El Niño, we adopted a definition which is based on the Nature paper published in 2014 by Vejusai. So here what they use wintertime total rainfall in the Nino 3 region, so which is larger than 5 mm per day. So using the definition, they show under greenhouse warming, the occurrences of extreme El Niño is doubling. And however, they highlight the mechanism is almost identical. It means almost similar. The thing is, here in present climate and future climate, we can experience SST warming in the eastern equatorial Pacific. Then that will lead to latitudinal shift of the ITCZ and as well as the Western Pacific convective zones. So then that will lead to more precipitation leading to extreme El Niño. However, in future there will be more occurrences. Then that occurrences mainly come from the warming in the region. It means they suggest this EEP region will warm more faster compared to the surrounding regions. So then, as they have already highlighted that extreme El Niño frequency is further doubling, so then we are interested what will happen in the CO2 reduction phase. First what we do, we cross-check their definition based on the observation, and then we can clearly identify which is similar to them. The definition distinctly identifies these recent 3 extreme El Niño cases. And also it clearly shows the nonlinear relationship between the Nino 3 rainfall with Nino 3 SST and meridional SST gradient. So then we apply this definition to our idealized CO2 experiment data, and then we examine the occurrences of convective extreme El Niño in present day climate, in the ramp up period, ramp down, and restoring. So clearly, as suggested by Professor Vejusai, we can clearly see under the global warming, the occurrences here in the present day climate, it is 8%. It is in the ramp up period, it is 16%. It means 100% increase or further doubling. The important point is this phase. In the ramp down period, it is further doubling compared to the ramp up period. So 16% to 34%. So it is 4 times compared to the present day climate. The thing here is, between this ramp up and ramp down, the selected period, the CO2 level is identical. It means for the same CO2 posing, there will be more occurrences. Then this highlight one thing. Most of the studies that focus on the future SST change, they highlight that we will experience some climate states during CO2 decrease that have not been experienced during the increase. So it means same CO2 posing but different climate states. And the other key point here is the restoring period, because here we drop down the CO2 level to the present day climate, the same level, but still we can see 75% increase. So it means even we come back to the present day level, there will be more cases. So what actually tell us is that we think that by reducing CO2, we can bring down our climate to the pre-industrial level, but that is not simple as we think. Right? So then the question is, why in the CO2 reduction phase there are more cases? So we further investigate this one. First, we look into the evolution of convective extreme El Niño. Here you can see the CO2 forcing in the black line. It is symmetric. However, the occurrences, evolution, it's look asymmetric. And also we can see the peak phase. There is a delay in the peak phase of the occurrences, which is about nearly 30 years. And at the same time, this peak phase does not decrease at once. It sustains nearly about 15 years. And the other point is, what we can see here is some kind of a hysteresis behavior. Hysteresis is the delayed response. So we show first frequency. So here this number of events, and if you compare, let's take year 2000 and 2280, the CO2 level is same, but the number of occurrences are high in this CO2 reduction phase. So it means there is a hysteresis behavior for the frequency. And here again, we show the precipitation of the maximum convective El Niño. And if you examine this one, even in the CO2 reduction phase, the maximum precipitation is high compared to the CO2 increasing phase. So it means it is further suggesting that we can have a hysteresis behavior for the intensity. And then the question is, what are the associated factors, or which one is controlling them? So here we identify three factors. The one is, we think about the delayed SST response. So this is already known case, because with the CO2 forcing, the SST response will be delayed, right? So it means this is the Niño 3 mean SST. In the ramp down phase, it will maintain warmer background state. So that is favorable for the occurrences of convective El Niño, because we know in the EEP, if we have warm SST, it will be supportive, right? And then, so studies suggest, initially they thought that this delayed SST response or delayed SST cooling is maybe because of the ocean's memory or the high heat capacity of the ocean. So it will allow the ocean to respond slowly. But one of the recent study published in Nature, they suggest that this delayed response is affected by aerosol effect and also the ocean thermostat delay. So because of that, we will experience some kind of a delayed warming. So however, for our case, it is important. We are interested about the warmer mean state. And at the same time, the precipitation response. And to the CO2 forcing, it is also asymmetric, but if you compare with the SST pattern, it looks roughly linear. So it means that precipitation is always following the SST. However, the case is here. With evolution, so here it follows at the same rate, but after a certain level, the two lines have different rates. And again, here in the restoring period, it is coming back at the same rate. So maybe here, just think that maybe in this Niño 3 region, this precipitation is not solely, maybe it's not solely dependent on the SST change. So it's not sure. And however, if you compare this mean precipitation change, the peak is further delayed from the SST. However, this peak phase is coincide with the peak phase of the occurrences. So it means that this may have some kind of a impact on this one. So why this is mean precipitation is increasing in this region? So some studies suggest that enhanced equatorial warming. So then that can contract the ITC. So it will enhance the rainfall. So that is for that their studies basically focus on this CO2 increasing phase. However, in another study, in the ramp down phase, they show that southward shift of the ITC, and that is may also supportive for enhanced precipitation in the region. So however, the point for us is, if we have high mean state, so then that will be supportive to exceed the precipitation threshold of 5 mm per day. And also in the venue size study that we adopted the definition, they suggest that the contribution from the mean precipitation change to this kind of extreme El Niño is about 50%. So it means that mean state change is not solely determining this case. So therefore, we are interested about the sensitivity in the region. So here we examine the sensitivity of SST and rainfall. So one study again recently published in Nature, it's 2021. So they show this one. This is the nonlinear relationship between the precipitation and the SST. So what they suggest is, if you observe these two curves, so this is for the present day climate and this is for the future climate. The PDF, it's almost looks similar. There are very slight changes. So it means this relationship will be shifted to the warmer climate, right? Without big changes. And at the same time, so it means this, at the same time they suggest the gradient or the slope is more steeper in the warmer climate. So by showing this one, they suggest in the Nino 3 region, the precipitation sensitivity will enhance under global warming, right? So then we examine this sensitivity change in our experiment. So as they suggested, you can see in this one, so this black line is for the present day. So this one actually in the Nino 3 region, D200 Nino 3 SST anomaly versus D200 Nino 3 rainfall anomaly. So as they suggested, we can clearly see the sensitivity is increasing in the CO2 increasing period. The thing is, if you're going back to the ramp down phase, even if you reduce the CO2, this sensitivity looks more stronger. So it means for a given weak SST, we can experience more rainfall. So then that may be another reason for why the frequency is increasing and also at the same time the sensitivity. So here in this period, it is more Nino 3 region is more sensitive for precipitation. So to further elucidate this one, we show the composite map. So this is for the composite precipitation anomalies for ramp up and ramp down. And this composite comes from Nino 3 index, which lies between 1 degree to 2 degrees Celsius. So if you examine this one, so in the ramp down phase, you can see in this region, there is more precipitation. Right? So by showing this one, we conclude that there is the frequency and intensity is increasing, and that may be related to the mean state change and as well as the enhanced precipitation response in the region. So now the question is, what is the impact? So again we come back to the motivation study. Here what they show actually is, by showing the precipitation difference in the land region, they show that some region will experience more precipitation, and then they initially attribute that to permanent extreme El Nino pattern. So then we want to see that, as we have already shown that there will be more occurrences in future, and then can we experience this kind of anomalous conditions? So to show this one, first we think of two factors. One is the precipitation pattern itself can contribute because the pattern is not changing, and if we have more cases in future, it will bring more precipitation. So first we show the composite of precipitation anomalies in ramp up and ramp down. You can see the pattern is almost identical, and at the same time we show the contribution to the mean state. If we have more cases in the CO2 reduction phase, it will contribute more. It will enhance better conditions. So then here we show this is anomaly difference for land surface temperature and precipitation. So between CO2 reduction phase and CO2 increasing phase, and then taking the difference here, we show certain regions will significantly experience more wet conditions. So, and with that one, here we conclude, we say that there is a hysteresis behavior for frequency and intensity of convective extreme El Niño in response to CO2 forcing, and that may be related to the delayed mean SST response and also precipitation increase. Here we think it may be related to the southward shift of the ITC during the CO2 reduction phase. And at the same time, we show that there is some kind of an enhanced precipitation response to given SST anomaly. And at the same time, if we have more occurrences, it will contribute to mean precipitation changes in certain regions worldwide. So with this one, I conclude the study. Thank you.
Okay, yes sir.
Could you show me the last figure?
This one? Yes.
So, what is your highlights of this figure? There's some kind of messages in here?
Yeah. It's to show the main impact, right? First, we want to show that the pattern is same, and then that pattern will enhance because we show that there are more cases and that at the same time the intensity is high. So that's why again I show this figure here, this kind of schematic diagram. So to show that this land surface temperature cooling is similar, right? Just to show the pattern is same. At the same time, to show in certain regions we will have more precipitation. So here it suggests that during a El Niño, so we can experience cool and wet conditions, right? So to show some identical result and then to highlight the impact.
Okay. Any other question?
Yes.
Figure 2.
This
Yeah,
one?
yeah. I can understand why the B figure.
Yeah.
Why the SST is like CO2, but I cannot understand why precipitation is like the SST.
Yeah.
Is it because of the?
Yeah, that is reasonable, right? The thing is now mainly we focus mainly studies highlight that precipitation follows the SST.
Yeah.
But here we think that this one is affected by some other things, right? Because this is about the mean precipitation change. Now let's say the ITC shifting, so it can contribute for the enhancement of the precipitation in the region itself, right? So that's kind of things. Here we just wanted to show the pattern and the mean state change.
I think El Niño 3 only considers some zonal contrast in the tropical Pacific. But ITCG, the El Niño precipitation is controlled by the other factor. It's like some in-time-specific temperature difference. So that difference can make this kind of mismatch.
And also your major implication of this research is some extremes will be more increasing. Even the carbon dioxide is removed.
Yes.
And also you use some kind of multimodal ensembles or each scatters on each ensemble.
Okay, so
represented.
you mean this figure?
Yes.
Okay.
Oh, then I'm guessing about that. How is the relationship between each ensemble? So, I mean, some models will make some more extreme cases, and some models make some less extreme cases. So, is these relationships are also valid in each inter-ensemble relationships too?
Yeah. So it means that the number of cases will be different,
Yeah.
but the frequency change is almost identical. Yeah. So we have cross-checked this one with also the CDR MIP, and the result is same. So we can see more occurrences.
More occurrences in the more extreme cases?
Yeah. Because here everything is based on the convective extreme El Niño. So I mean more occurrences mean more extreme cases.
One thing that I wonder is the extreme El Niño is more depend on simply Eastern Pacific temperature
Yes.
or east-west the zonal gradient. Which one?
Yeah, both are important. But however, the localized warming in the eastern equatorial Pacific cannot induce this kind of thing. The gradient is important. It is not the zonal, also the meridional, right? So the gradient should be weakened. Otherwise, if the eastern Pacific is warming at the same rate and the western Pacific also same, there will be no change in the gradients, just warming,
Yeah.
and that will not. That means that will not lead to this kind of events.
So you
Yeah.
mean the gradient would be important?
Yeah. Gradient is not would be important. It is important. It has been proved.
Then I think I'm not sure there is a kind of this study, but
Yeah.
because you mentioned that the zonal gradient or Pacific zonal gradient,
Yeah.
Pacific SST zonal gradient would be important for the frequency and convectivity of this extreme El Niño.
Yes.
I thought that as as Kyungmin mentioned, the kind of inter-ensemble spread, but here I want to think about intermodal spread in our CMIP6 or CMIP5 model.
Uh-huh.
Their zonal SST gradient is quite tightly coupled with the sudden ocean heat
Changes.
uptake.
Okay.
So that so this full story might it was like possible that the southern ocean heat uptake diversity
Mm-hmm.
might lead the east-west SST asymmetry in Pacific,
Mm-hmm.
and as your result that might be lead to the intermodal diversity of convective extreme El Niño.
It's
I
possible.
think maybe.
Yeah, so you can do that. That's good suggestion. So I think it's we need to work on. Yeah, so I think you can do that. Yeah. Okay.
And I also have one more question there. As previously, the Xin showed that there is some asymmetry between the El Nino and La Nina, and also the as Kai makes one paper for the El Nino and one paper for La Nina. So is there any asymmetry on the La Nina too on this relationship?
Actually, we didn't focus on that one. So I
Not
cannot
now.
clearly give some answer at this stage. We just need to check.
Only
Yeah.
the La Nina.
However, when I refer to some studies, they say the frequency of La Nina also increasing. Yeah, but we need to check in this experiment and see what's happening.
This is a convective idea. This is
Ah.
very convective.